Good morning, all. I'm Mahin Fatima, studying CSM in Srinivas Ramanujan Institute of Technology. My basic electrical engineering assignment topic is PMMC instrument. Let's go into the topic. First, measuring instruments. The instruments used for measuring the physical and electrical quantities is known as measuring instrument. Next, permanent magnet moving coil. It can be written as PMMC, that is permanent magnet moving coil. Instrument is a widely used instrument in the field of electrical engineering for measuring current and voltage in different current DC, especially DC circuits. Its popularity is due to its accuracy, reliability, ease of use. Next, PMMC instrument is a type of analog meter used for measuring electrical currents. It employs a permanent magnet and coil to deflect a pointer displaying the current value on a calibrated scale. Next, we have working principle of PMMC instrument. When a current carrying conductor is placed in a magnetic field, the force is produced on the conductor, that is coil. This force tends to move the coil in the space. Next, we have construction of PMMC instrument. A coil is wound on aluminium former which is supported by spindle. The two ends of spindle are supported by jewel bearing. Iron cylinder is placed inside the coil and this assembly is surrounded permanent magnet coil carries current to be measured. The current is fed into and taken into from coil from springs. Flexible ligaments are provided to make provision for this connection. And deflecting torque is produced as described in the working principle. Controlling torque is achieved with springs and damping torque is provided with the help of aluminium former. The deflecting torque, that is TD, is directly proportional to current, hence the scale is uniform. Next, what is permanent magnet? At the core of PMMC instrument lies a permanent magnet. It is usually made of strong magnetic materials like alnico. It is an alloy of aluminium, nickel and cobalt or rare earth magnets. The permanent magnet generates a steady magnetic field within the instrument. Next, moving coil. It is a delicate coil typically consisting of numerous turns of fine wire is mounted on a pivoted spindle. This coil is the heart of the instrument and is responsible for the measurement of electrical quantities as shown as given in the figure. It is a permanent magnet moving coil. Next, damping mechanism. To prevent the pointer from oscillating excessively and to ensure smooth and accurate readings, a damping mechanism is incorporated. This usually involves a vane attached to the coil moving through a magnetic field or air which offers resistance to the coil's movement in appropriate units. As we can see in this figure, we have PMMC and we have pointer, spring, balanced weight, jewel bearing and uniform scale. Next, pointer and scale. A pointer is fixed on the coil spindle and its movement is synchronized with the coil. As the coil experiences the mechanical force due to the interaction with the magnetic field, pointer moves over a calibrated scale displaying the measurement in appropriate units. Control springs. Precision control springs are utilized to provide the necessary torque to the coil, allowing it to return to its original position when the current through the coil is zero. These springs ensure that instrument is not affected by external vibrations or disturbances. Next, we can see the various parts of PMMC and their functions. First, permanent magnet. It is made up of ferromagnetic material and its function is to produce magnetic flux. Next, iron cylinder made of magnetic material, and its function is to strengthen magnetic flux linkage. Coil made of copper, function is to carry current and produce deflection. Former made of aluminium to support coil and to produce damping torque. Spindle made of steel to support the coil and to provide means for rotation. Flexible ligament, it is thin steel strips to provide connection to meter, terminal and CC. Next, spring is made of phosphor bronze to provide leads for incoming and outgoing connections. Next, pointer, it is made of aluminium like former to show reading on calibrated scale. Next, housing. The entire assembly of the PMMC instrument is enclosed within a robust housing made of non-magnetic material. This housing not only protects the delicate components from external damage but also shields the magnetic field from external influences. We have principle of operation of PMMC instrument. It is the fundamental principle governing PMMC instrument, that is permanent magnet moving coil, is based on interaction between magnetic fields and electrical currents. When current flows through a coil placed in magnetic field, mechanical force is generated causing a pointer movement indicating measured electrical quantity on a calibrated scale. Next, we have some advantages and also disadvantages of PMMC instrument. Let us see the advantages. Deflection is proportional to the current, that is TD is directly proportional to current I. Power consumption is very low. High accuracy due to high torque to weight ratio. Sensitivity is high because of strong magnetic flux. Errors due to stray magnetics are also small because operating magnetic field is strong. It is free from hysteresis and stray magnetic field errors. Uses effective damping method, that is eddy current damping system is high, and single instrument can be used for different currents and voltage ranges using shunt and multiplier. Torque to weight ratio is moving system is high. Despite these advantages, we also have some disadvantages of PMMC instrument. It is suitable for DC measurements only. Cost is higher than moving iron instrument. It is the strength of permanent magnet decreased due to aging. Delicate construction, so to be used with care. Next, thank you for giving me this wonderful opportunity. I hope you found this video insightful. Have a nice day.